first question, in a young double slit experiment, the source is white light. One of the hole is covered by a red filter and another by a blue filter. In this case, so we need to understand that the condition for observing interference, the initial phase difference between the interfering waves must remain constant. Otherwise, the interference will not be sustained. The frequencies and wavelength of two waves should be equal. If not, the phase difference will not remain constant, and so the interference will not be sustained. So the light must be monochromatic. This eliminates overlapping of pattern as each wavelength corresponds to one interference pattern. Here in this problem of the Young's double slit experiment, when one of the hole is covered by a red filter and another by a blue filter, in this case due to filtration only red and blue light are present. In Young double slit experiment, monochromatic light is used for the formation of fringes on the screen. Hence, in this case, there shall be no interference fringes. The wave front emitted by a narrow source is divided in two parts by reflection, refraction, or diffraction. The coherent sources so obtained are imaginary. So, correct answer for this question is option C, that there shall be no interference fringes. Looking towards the next question, figure shows a standard two-slit arrangement with S1, S2, P1 and P2 are the two minima point on the either side of P. At P2 on the screen there is a hole, and behind P2 is a second slit arrangement with slits S3, S4 and a screen behind them. So, wavefront, we need to understand the points of the wavefront, that every point on the given wavefront act as a source of new disturbance called secondary wavelengths, which travel in all directions with the velocity of light in the medium. A surface touching these secondary wavelets tangentially in the forward direction at any instant gives the new wavefront at that instant. This is called secondary wavefront. In the given question, there is a hole at point which is a maxima point. From Huygens principle, wave will propagate from the source S1 to S2. Each point on the screen will act as a secondary sources of the wavelength. So correct answer for this question is option D, that there would be a regular two-slit pattern on the second screen. So correct answer for this question is option D. Looking towards the next question, consider the diffraction pattern for a small pinhole. As the size of the hole is increased, the size decreases, the intensity increases, the size increases, or both A and B. So the central bright disk is known as Aries disk. As the size of the hole is increased, the size of the disk will decrease. As the size of the hole is increased, the width of the central maxima of the diffraction pattern of the hole decreases, since the same amount of light is now distributed over a small area. So as intensity is inversely proportional to area, the area is decreasing, so area intensity increases. So correct answer for this question is option D, as both A and B. The size decreases and the intensity increases. So correct answer is option D. Looking towards the next question, consider sunlight incident on a pinhole with the width 103 angstrom. The image of the pinhole seen on a screen shall be a sharp white ring, different from geometrical ring, diffused colored region around a sharp central white spot, or both A and C. So first of all, diffraction of the light can be observed only in the size of obstacle or aperture. is less than the wavelength of light. Now your given is width of the pinhole is 103 angstrom. That is 1000 angstrom. We know that wavelength of sunlight ranges from 4000 to 8000 angstrom. So clearly wavelength is less than the width of the slit. Hence light is diffracted from the hole. Due to the diffraction from the slit, the image formed on the screen will be different from the geometrical image. So the correct answer is option D, that is both A and C, a sharp white ring and a diffused color region around a sharp central white spot. So correct answer is option D. Looking towards the last question, consider sunlight incident on a slit of width 104 angstrom. The image seen through the slit shell. So first of all, a diffraction of light is the phenomenon of bending of light around the corners of an obstacle or aperture of the size of the wavelength of light. So first of all, that no diffraction phenomenon is observed as the size of the slit is very large compared to the wavelength. There will be diffraction of the light as size of slit is compared to the wavelength of the light incident. So here in the question, it is given that width of the slit is 104 angstrom. That is 104 into 10 raised to minus 10 meter. That is 10 raised to minus 6 meter or 1 picometer. So wavelength of visible sunlight varies from 4000 to 8000. Hence the width of the slit is comparable to that of wavelength. Hence diffraction occurs with maxima at center. So at the center all colors appear. That is mixing of colors form white patch at the center. So the correct answer for this question is option A, that shall be a fine sharp slit white in color at the center. So correct answer is option A.